We are talking about arcs, chords, and tangents. And the objectives, we want to recognize and use relationships between arcs and chords. We want to recognize and use relationships between arcs, chords, and diameters. And we want to use properties of tangents. So these theorems are all numbered names of. They're all named by numbers, and we're not going to have you recall these for a test or anything like that. They're just to designate between the different theorems. But we just basically want to understand the gist of them and be able to apply them to practice problems. So in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So here we have line segment FG. So line segment FG is right here, and that is congruent to line segment HJ. And the only way that those two can be congruent if they're minor arcs in the same circle, the only way that can happen is if the arc FG, so arc FG is congruent to arc HJ. So arc FG is congruent to arc HJ. Theorem 10.5. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So here we have line segment FG again, and I'm going to put 3 marks on this one, is congruent to line segment HJ. So there's HJ again. And the only way that those can be congruent is if the distance from L to X is equal to the distance from L to Y. So I'm going to put 2 congruent marks here and 2 congruent marks here. Also, that has to intersect at a 90 degree there. Next, we have theorem 10.10. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So in this case, we have our perpendicular line right here. And then ST has to be the radius, so we can put an R there. That's the radius of the circle. And then we have our tangent line. There's our tangent line there. So line L is tangent to circle S if and only if L is perpendicular to ST. So there's line L, and it's perpendicular to ST. Next we have 10.11. If two segments from the same exterior point are tangent to a circle, then they are congruent. All right. And in order for these to be tangent, that means the only way that they can be tangent is if they form right angles with the radius. So if we draw a radius from point D up to point A, and we draw a radius from point D down to point C, if line segment AB and CB are congruent, this has to be a 90 degree here, and this has to be the radius. So this is just a little extended version of 10.10. Now we just say that if there's two tangent lines that connect at the same point, which in this case they connect at point B, then the only way that they're tangent, that AB and CB are both tangent to the circle, is if they are congruent.